Welcome back to Educate Science Solutions. Today, we are going to discuss the topic correlation and regression, which is one of the most important topics of biostatistics. So, what is correlation? It is a statistical tool for measuring the degree of relationship between the two variables, which is a change in one variable results a positive or negative change in another variable. Now, the measurement of this correlation is done with the help of a mathematical tool called as coefficient of correlation, represented by R, and its range from -1 to +1. Now, various types of correlations. This may be either positive or negative correlation. Like if there is a rise in one variable gives a simultaneous rise in another variable, then it is positive. Else, if there is an inversely relation between the two, it is negative correlation. Now, as goes for the linear and non-linear correlation and simple, multiple, and partial correlations. Now, the perfect positive correlation, when the two variables are directly and fully correlated with each other. This is perfect positive correlation. The value of R or coefficient of correlation is +1. Same goes for perfectly negative correlation when two variables are inversely proportional to each other, and here the coefficient of correlation is -1. Partial positive correlation, when there is a non-zero values of correlation, coefficient lies between 0 to +1. Now, partial negative correlation, in this case, the non-zero values of correlation coefficient lies between -1 to 0. No correlation, when there is a no relation between the two variables and the coefficient of correlation is 0. Now, when we go for simple correlation, it deals with the two variables. When we find correlation between two variables, it is simple correlation. Now, partial correlation, here we consider three or more than three variables, but the relation should be found between the two variables only. Now, multiple correlation, when we find correlation between more than three or more variables, then it is multiple correlation. Now, linear correlation, when there is a linear relationship between, like if there is an increase in value of one variable, there is also should be an increase in another variable, or increase or decrease, like either directly or inversely relation should be there. And non-linear correlation, here the amount of change in one variable does not bear a constant ratio to amount of change in another variable. Now, there are various methods of studying correlation, which is either graphical method or algebraic method. Here, graphical method, the most important method is scatter diagram, which gives us a overview of the correlation between the two variables. And there we goes for the algebraic methods. Here there are two methods, which is Carr-Pearson's coefficient of correlation and Spearman's Rank's coefficient of correlation. Now, first of all, we discuss the scatter diagram, also called as dot diagram method. This is a diagrammatic representation of bivariate data, and it is the simplest graphical device of showing the correlation between the two variables. Here, the data is plotted against each values of pairs values and of two variables by dots. Right? See how it is done. At x-axis, we consider one variable. At y-axis, we consider another variable. We put the values and make a dot here, and we form an imaginary line across these dots, and that line shows us how the two variables are correlated. Now, if there is a perfect positive correlation, the line should be like the initial first one. Then highly positive correlation, the lower positive correlation. You see, the in perfect positive correlation, all the dots were coming on that imaginary line. Like in highly positive correlation, the dots were somewhat much closer in to the imaginary line. Then we consider to the low positive correlation, where the dots are somewhat scattered, but in a same direction to the imaginary line. And no correlation, there should we can't make any imaginary line, because the dots were so far scattered, and there is no relation in the direction or distribution of the dots. Now, same goes for low negative correlation, high negative correlation, perfectly negative correlation. Now, we consider the mathematical basis, which was the most accepted, because it gives us the most accurate values, and gives us the mathematical values. In the earlier scatter diagram, it was just like an overview, not getting the accurate values, but in Carr-Pearson we will get the accurate value. So it is the most widely used mathematical method of measuring correlation. It is based on the covariance of two variables in a series. Now, here R is called as the Carr-Pearson's coefficient of correlation. Now, there's the formula which you can see in the screen, very simple, where you can see dx is x1 minus x bar, and dy y1 minus y bar, and their squares. Right? Now, best way to understand this is through a example. So here is an example to calculate the correlation of coefficient between x and y from the following data. Now there is a data given, like for x it is 5, 9, 13, 17, 21, and for y it is 12, 20, 25, 33, and 35. Now first of all we have to make a table. We put the values of x, we take out the mean of that x, which is called as the x bar, and then we find the differentiation between x minus x bar, right? So that becomes our dx. Then we take the square of that dx every time. Then the same process goes for the y. We make sure we find out the dy, we find out the dy square, and then we will just multiply our dx and dy, right? Then we summation it, which comes around 236. Now we put the values in the formula where r equals to summation dx dot dy upon under root summation dx square into summation dy square. When we put the values in the formula, we'll get an value of r approximately 0.986, which shows there is a high positive correlation, right? Because the value is say above 0.5 and just below +1, so it was not perfectly correlated but perfectly positive correlated, but it is highly positive correlated, right? So now there are certain properties of Karl Pearson's coefficient of correlation. Like the coefficient of correlation is a measure of closeness between the two variables. As you have seen in the example, we have find out like how close the two variables are, and the answer is they are highly correlated, right? The correlation may be positive and negative. Yes, we know that it goes from highly positive to highly negative, and even perfect positive to perfect negative, right? The range of correlation coefficient is from -1 to +1, as we have seen earlier also. If r equals to +1, correlation between two variables is perfect and positive. If r equals to -1, correlation is perfect and negative. If there is a strong positive relation, then the value of r was close to +1. Then same, if there is a strong negative relation between two variables, the value of r close to -1, and if r is 0, then there is no correlation. Now we consider the Spearman's rank correlation coefficient, which is also called as concurrent deviation method. Now this method is used when we have to just find out the qualitative variables, when the variables were not quantitative, not any certain, like example, if we consider like intelligence, like beauty, like honesty, right? These are all the variables which we consider as qualitative, not quantitative. If we are getting quantitative variable, we will use Karl-Pearson's method. If we will get qualitative variables, we will use this Spearman's ranks correlation coefficient method, right? So the product moment correlation coefficient is calculated on the basis of values of this variable, but quite often situation arise in which data cannot be measured quantitatively. In this case, rank correlation method is applied, right? So आपके पास जब क्वालिटेटिव वैल्यूज आती हैं, वेरिएबल्स आते हैं, तो उनमें कोई नंबर्स होते नहीं, तो एनालाइज करना उनके लिए बहुत मुश्किल होता है. तो वी विल रैंक देम, राइट? हम इंटेलिजेंस को रैंक के अकॉर्डिंग प्लेस करते हैं, ठीक. ब्यूटी को हम लोग पॉइंट्स देते हैं कि 7.2 स्टार का है, ये 8.5 आउट ऑफ 10, राइट? तो वी विल असाइन सर्टेन रैंक्स. तो उस तरीके के लिए हम लोग ये मेथड यूज करेंगे इफ क्वांटिटेटिव वेरिएबल्स फॉर देयर, राइट? आर, हियर द फॉर्मूला आर इक्वल्स टू 1 minus 6 summation d square upon n cube minus n, right? And right, where r is Spearman's ranks correlation, d difference in ranks for each pair, and n is equals to number of observations. Now consider it with help of an example. The marks obtained by the students in zoology and botany are as follows. The marks in zoology, which is 35, 23, 47, 17, 10, 43, 09, 6, and 28. Marks in botany, same goes for 30, 33, 45, 23, 8, 49, 12, 4, and 31. Now first of all, we will make a table, put the marks of zoology in the table, and we will arrange them. We will assign the ranks to these marks. Like the highest goes for 47, so we will rank it first. 35 ranks goes to 3, ranks 3, and so on, right? Same for botany, we will assign ranks to the numbers, and then we find difference between the ranks of zoology and botany in a same line, in a same row, which is. And then if we want to d square, then we will make the summation of d square. Then the r equals, we will put the formula in this Spearman's correlation, which is r equals to -1 minus 6 summation d square upon n cube minus n, or say that n bracket n square minus 1 bracket close. Now we will put the formula. The answer goes comes around 0.9, which is, we can say there is a high positive correlation between the variables. So now regression. Regression is used to denote the estimation or prediction of average value of one variable for a specified value of other variable. Now here the one variable is called as independent variable, जिसकी मदद से हम लोग डिपेंडेंट वेरिएबल की वैल्यूज़ को डिटरमाइन करते हैं. So this method is developed by Sir Francis Galton in 1877. There are certain uses of regression analysis, like it provides estimation of values of dependent variable from the values of independent variable. It is used to obtain a measure of error involved in using the regression line as the basis of regression estimation, and with the help of this regression analysis we can obtain a measure of degree of association or correlation that exists between two variables. Now the various types of regressions. So it is the simple regression when there is only a single independent variable used to predict the value of dependent variable, then it is called a simple regression. Multiple regression. Here the dependent variable is functional of two or more independent variables. Like the value of dependent variable should be determined with the help of two or more than two independent variables, then it is a multiple regression. Now linear regression, if there is a linear relation between the dependent as well as the independent variable, which is also called as predictor, then it is called as linear regression. Non-linear regression, if dependent variable has non-linear correlation with predictor, the scores of the criterion have to be predicted in terms of a curved line. Now regression line and regression equation. So regression equation are algebraic expression of regression lines. Let us consider two variables x and y. If y depends on x, then the result comes in the form of simple regression, right? There should be a single independent variable. Now if we take case of two variables like x and y and have two types of regression lines, like regression line of y on x and regression line of x on y, then it is a multiple regression. Now you can see the value of slope y equals to a plus bx. Now regression coefficient. So this is a mathematical tool used to determine the value of regression. It is denoted by b, and regression coefficient of x on y equals to bxy, and regression coefficient of y on x should be denoted as byx. Now there are various methods, like if we are using the correlation coefficient r and standard deviation, then the value of this regression coefficient can be determined as equals to r into standard deviation of x series upon standard deviation of y series. Now if mean is known, then we can find out the value of this regression coefficient, which is equals to summation dx into summation dy upon summation d square y, and same goes for byx. Now there's also a direct method for determining this regression coefficient, which is bxy equals to summation xy minus summation x into summation y upon n whole divided by summation y square minus summation y whole square divided by n, and the same goes for byx. Now there are certain properties of regression coefficient, like the coefficient of correlation is a geometrical mean of two regression coefficient, which is r equals to under root byx into bxy. Now if one of the regression coefficient is greater than unity, the other should be less than unity. Like if byx is more than 1, then bxy should be less than 1, right? Though regression coefficient will have the same sign as that, they will either positive or negative, right? The coefficient of correlation will have the same sign as that of regression coefficient, and the average value of two regression coefficient would be greater than the value of r. Now regression coefficient are independent of change of origin but not on scale. So here are this topic regression are also completed. So our correlation and regression topics were completed. Now there's certain bibliography. The content were taken from Daniel and Cross books, Biostats, then from Pranab Kumar Banerjee, Introduction to Biostatistics and Statistical Methods by Blackwell. So thank you for watching this video, and please don't forget to subscribe the channel.